So, good morning, bonjour, welcome to this SDWAN Summit. It's a lovely morning. I'm pretty excited. Thanks very much for showing up right at the start of the conference. My name is Carsten Rossenhoevel. I'm the CTO and co-founder of EANTC, that's the European Advanced Networking Test Center and Independent Test Lab in Berlin, Germany. And it's my pleasure and a privilege, I'm pretty honored to have the first slot this morning, starting with a tutorial about the SD-WAN technology. So, you know, SD-WAN is exciting for everybody. It has taken off like crazy. We're in the middle of a lot of trials and POCs and deployments starting. And so I thought when I developed this tutorial together with our team in Berlin, you know, there are probably every presentation is going to be excited, is going to sell the technology, is going to explain like what are the cool things you can do with it. So there is no lack of that side of the story. As a test lab, our role is to validate the scenarios and to check how they're actually working. And I've been doing this for 18 years now in our company since I spun it off from the Technical University of Berlin. And it's also exciting. It's great. I love the job. And I also love that we can actually take all these marketing slide decks and we can link them with reality. And without becoming too pessimistic, that's what I plan to do this morning in the next 2 hours together with you to go through SD-WAN requirements, challenges, solution aspects, features that need to be taken into account to give you some guidance in like what's possible with the technology, how complex it can be, what requirements to take into account when deploying it. And I hope that these slides can serve maybe as a way to get through the other conference presentations and to check like, okay, what is this vendor offering that area? What is that vendor promising in this area? And how do they actually prove themselves? So we have roughly 2 hours, maybe a little more, and there will be a coffee break at 11 a.m. I'll actually speak until 11 for the first 2 sections. Then we'll have the rest after the coffee break, and there will also be a Q&A. I thought there should be a Q&A at the end, but if you have any burning, pressing questions, feel free to raise your hand, and then we can sort it out before the coffee break as well. But let me get started. So first, if you don't know EANTC, we're an independent test lab. We're not selling any SD-WAN solution. We're not integrating any SD-WAN solution. We're only testing things. We've been around for quite a while, for more than 20 years in total. And what's pretty unique about us is that we test with both the manufacturers and the network operators. So from the manufacturer testing, we get introduced to new technologies pretty early in the life cycle. And from the operator side, we get down to earth with real deployments and real requirements. We actually do support testing from the test strategy through the POC cycle, acceptance testing, audits and certifications, and we basically support the whole life cycle of testing. I don't want to get too much into the basic propaganda here. Let's just get us started. And also just to touch upon some other activities that we're doing, or some major activities. We're mostly focused on NFV and SDN testing these days. We have 2 pillars, interoperability and performance testing. And on the performance testing side, we work together with the Intel Network Builders program to validate vendor solutions for performance and scalability and resiliency. We have a big showcase on the MPLS and SDN and NFV side in March every year, together with the wonderful organizers of this conference, Upperside Conferences, at another hotel in Paris in March. We have currently a very large testing initiative with a new IP agency that's a non-profit organization doing NFV interoperability testing. And we do a couple of other tests. Of course, I'm going to talk about the SDWAN initiative here this morning, but we also do participate in a multi-lab initiative for network security testing innovations, so we want to get it to the next level. And finally, acceleration lab testing, where we evaluate hardware acceleration solutions for telco cloud environments. So these are only a couple of our test programs. In general, we cover technologies from IP up the layers, everything that has to do with packets, and mostly focusing on the innovative areas. So regarding the MPLS in SDN and NFV interoperability showcase that I introduced, I'd like to do a little bit of advertisement for it because it's run by the same conference organizers, and it'll actually happen in April next year, April 10th to 13th at the Marriott Rive Gauche here in Paris. And that's a huge conference where we are going to have a big live showcase, typically with 8 or 10 racks, more than 15 participating vendors, and public live guided tours. So we're going to look at the latest innovations in multi-vendor SDN solutions and packet transport solutions. So enough for the introduction. Let me walk you through the agenda. Basically, we've prepared 7 areas this morning for this morning's tutorial. First, I'd like to talk about the requirements, the key design requirements, what is actually needed, to get a good SD-WAN design going. Then let's talk a little bit about solution parameters, which parameters actually influence the solution. What do you need to take into account in terms of scalability? How large does something need to scale? How does it need to scale, for example? Then, as I said, I think that will be the time for the coffee break. After that, I'm going to talk about the challenges. You know, if you look at SD-WAN at the first glance, it looks like a very easy overlay technology, but of course there are challenges, and it's good to know and think about them to avoid them. And similarly, implementation pitfalls in section 4, how to avoid them is another part of this, this presentation after the coffee break. Then I'm going to look very briefly at industry standardization efforts. The MEF is one of the organizations aiming to standardize reference architectures and service models. Not the only one, but I think one of the major ones. And then in the 6th section, I'm going to explain what would be a typical test coverage. So from the proof of concept perspective, like what should be actually taken into account. And in section 7, I'm going to talk about a case study. So if you look at the published agenda, it looks a little different because Remy and our team and I prepared it a couple of months back. And we actually wanted to publish a pretty major test program, the results of a pretty major test program, together with participating vendors as part of this launch here today. And what happened is actually quite typical for the industry. So we had 2 vendors who had actually commissioned us, and one of the vendors postponed the testing because they don't have enough skilled resources available, and that's a problem in the industry throughout. You know, any innovation comes with a lot of requirements for good experts that actually master the technology and can implement it successfully. And so we were left with one vendor, and that vendor, we ran actually the tests in their lab. We prepared a report, and we got the final no-go decision from the vendor this morning at 8 a.m., where they said the results are not as they wish they would be, and I tend to agree. So we're going to retest with the vendor and then publish later on. So unfortunately, I cannot talk about any tangible results here. What I will do is in the section 7, I'm going to introduce you to some of the test scenarios that we did. I'm going to show you some of the slides, but I'm not going to talk about results, and I've actually blackened the vendor name. So that's as far as the life of an independent test lab goes when you try to validate something independently. So let me start with the requirements. What are the benefits that service providers and enterprises actually expect from SD-WAN? So this is a slide, an analysis coming from Heavy Reading from December last year, from their work operator views on emerging SD-WAN survey. And as you can see in the bottom line, that's the most important feature, important for 48% of the respondents as critical, the ability to add new features on demand via software. And the next important one, the next most important one is speed and agility in adding and managing new locations. So these two together have to do with manageability and provisioning speed. And soon after comes security and low-cost connectivity. So we have a couple of goals already. Manageability, managing something complex, very straightforward, with high security and being low cost, which already tends to become a conflict of interest or conflict of goals. Because obviously, if something is complex, it's difficult to make it low cost. If it's low cost, it's difficult to make it secure. So you can see that it's a non-trivial thing that we have here. And of course, SD-WAN has a ton of solutions. There's a very active market. And I think the differentiation typically comes with the how the vendor solutions actually manage to combine these conflicts of interest, how to combine these goals. And as long as, let's say, a small enterprise wants to connect 2 or 3 branches and they just throw 2 or 3 tunnels full mesh, that's not a major challenge, right? And I don't need to test about it. You guys don't really need to think about a complex product. If you're a service provider, you don't need to run a proof of concept if you're an enterprise. That's actually straightforward. But that's not what SD-WAN was designed for. Because in that case, you can just basically install 2 Linux boxes, run an IPsec tunnel with some routing over it, you're basically done. So SD-WAN was designed to be flexible, to allow a very agile environment where many branches are supported, a lot of changes in the network come up, a lot of new locations are connected, multiple tenants are connected, very specific security policies about internet breakouts, for example, are used. So all of the complexity is the fun thing about SD-WAN. So it's important to look at how this actually combines with each other. So then the interesting question, of course, is the improved application performance, and I'm going to talk about that in more detail. So steering flows over appropriate networks. Of course, it's good to always use the most reliable network, but that's also very expensive. So everybody wants to use the internet for as much traffic as possible. But then the question is, how much can you actually put on the internet? At what point does it get too risky? At what point does it get too unpredictable? And how to counter that unpredictability? Are there maybe ways to counter that? And although I'm sure you'll hear a lot from the vendor presentations this week, I'm also going to talk a little bit about that. And the next point here is multi-gigabit broadband connectivity. So multi-gigabit is wonderful. Heavy Reading has a lot of analysis going on in the United States. That's a very specific market. But here in Europe, multi-gigabit broadband connectivity on the low-cost side for consumers is actually quite hard to get. And I'm going to show you a slide that shows how many locations in Germany and in other countries are even connected with more than 15 megabit per second broadband access. So it's not that easy to get multi-gigabit connectivity as well. And surprisingly, the least important part here was peace of mind from managed service offerings. So people are not afraid of managing things themselves and of managing some more complex scenarios. I think that's some good news. So what are the aspects that are important for SD-WAN deployments? We identified a total of 8 areas. Of course, you can slot them differently, but I'm going to go through each of them and explain to you what we think is important. So scalability. Of course, scalability is one of the major points. From the service provider perspective, if a service provider deploys an SD-WAN solution, it must be able to support multiple tenants. That's the number one knockout criteria. Because if it's only a single tenant solution, it's going to be a custom-built environment again. And I've seen many custom-built environments. They are wonderful, but they are also extremely expensive to maintain, and they're unicorns. So they don't work for multiple customers. And exactly what we want to have here is a solution that can be applied once and for all for everybody, that has a user portal that can just be provisioned or more or less automatically and just works. And I think from all of the press releases that I've seen from service providers in the recent past, that's exactly what they are looking for. So multi-tenancy support is an absolute knockout criteria. But then the things become more interesting. So how many tenants do you actually want to put on such a network? Of course, you can say, well, how many small and medium-sized enterprises do we have in our country? 500,000, 1 million. Wonderful. But with that requirement, nobody's going to be able to fulfill. Or, setting up the whole environment with controllers and user portals is going to be way too expensive. So it's important to understand how many tenants are really required. Small and medium-sized enterprises are a difficult bunch. They're difficult to access, to access the market. So if it's only large enterprises that are actually the target, then the number gets much smaller. But if you're actually targeting large enterprises, then the interesting point becomes like, how many VPNs per tenant do they want, and how many total VPNs? So let's say you have a large chemical factory, chemical manufacturer that's active worldwide, or a machinery industry manufacturer. Those guys will probably want to have many, many different VPNs that are running in parallel. They don't run all of their traffic over the same segment. So that makes the whole management more interesting and more complex. And the total number of VPNs also reaches some limits in terms of the number of IPsec tunnels that are supported, for example. And finally, the number of the managed CPEs is also interesting. There are some enterprises out there who have like a ton of office locations or branch locations. Let's think about supermarkets, drugstores, insurance companies. And these might come with requirements that say like, okay, we only need 2 or 3 VPNs, but we need 1,000 locations. And the complexity of connecting all these 1,000 locations quickly becomes a challenge. So the number of managed CPEs is one of the major scalability issues or questions as well. And in the best case, the communication will only be between each branch location. Let's take the supermarket example, and the headquarters. Maybe I'm sure there are like 2 different locations for resiliency, but usually that would be a hub and spoke communication. But then if maybe they run voice over IP over this network as well, or they run any sort of other applications, maybe they want to talk, with each supermarket branch in the same city or in the same region, or multiple locations. So at some point, usually a hub and spoke environment morphs into a partial mesh. So the number of tunnels actually increases. And in the worst case, there will be full mesh requirements. Pretty rare, I would think, depending on the industry sector. But in the worst case, there will be a full mesh, which obviously has an n² number of tunnels required. So this slide doesn't talk about the attachment of different types of technologies, but you can see it already in the diagram. There is internet, there is an MPLS wide area network, there's a wireless network connected here, and those typically have to be combined for budget reasons and also for coverage reasons. And SD-WAN, I think, is best when it covers all 3 of these technologies. Especially the mobile technology should not be underestimated, because It's very important that such a network can be delivered, such a technology solution can be delivered on net and avoiding all of the provisioning delays that typically come with any off-net connectivity. If you have, if a service provider has to contract with another service provider for a leased line, an MPLS service, whatever. And obviously only using the internet as access is going to get us into other types of challenges, as we'll see. So the test cases that our company is typically running for scalability, these are just some examples from typical test topologies, are scaling the customer sites on the left-hand side, scaling the VPN tunnels per the CPE, in the center, and scaling the tenants at the head end. So the scalability of customer sites is a pretty realistic test case. Unfortunately, it's also one that requires a ton of equipment. So, and that's difficult to get in an individual POC. So how many customer sites would there be? I said could easily be 1,000, 2,000 or more. But then you need actually 1,000 or 2,000 or more CPEs. And those CPEs need to be set up. They need to be managed. They need to be available in the lab. You need to have space in the lab. And running 1,000 CPEs in the lab is not a trivial thing. It requires a lot of cabling. And usually when you're done provisioning all of this, the first power supply of one of the 1,000 fails and you start maintaining, running maintenance. So typically we run these scalability tests with virtualized solutions. So let's say we have a couple of real CPEs and then we complement them by virtualized implementations of the SD-WAN protocol stack from the vendor on some cloud infrastructure. So that's how we scale customer sites. Scaling the VPN tunnels, I think, is pretty straightforward. It's not such a huge requirement as well. And scaling the tenants at the head end is also straightforward. The question is, why do we need to have this? A head end would typically be one head end per tenant. So why do we need to scale the tenants at one head end? The point is that cloud integration becomes more and more important. So if most of your tenants are actually connecting to, let's say, Amazon or to another cloud provider, there are going to be a lot of tenants at this one head end. And of course, that cloud provider is going to make sure that the traffic remains isolated and separated and secured. But still, there are going to be a lot of tenants that want to connect to this cloud operator. So that's why scalability of the tenants at the head end is also important. So these are some scalability test cases. The next question is performance. Performance traditionally has been very well understood. We've been running data plane throughput tests with IP for 20 years now. So what's the problem with this? Now, SD-WAN has a couple of challenges. The first one is traffic is encrypted, obviously, because it's potentially running over the internet. So everything needs to be encrypted. The whole service needs to run with low latency and with low loss, of course. So it should be as performant, that's at least what people expect, as performant as an MPLS service. And the performance should not be degraded if the packets become larger. And that's actually one of the major issues that we've seen in one of the vendor tests recently as well. So the diagram here on the left side shows a typical IP packet. It has a normal IP header, 20 bytes, and then it has some payload, typically up to 1,500 bytes, or in data center environments, 2,000 bytes. And as you know, the maximum for jumbo frame is 9,000 something, but that's not that important. So it's important to support the 1,500 or 2,000 bytes. Now, for any SD-WAN service, additional headers need to be attached, prepended to each IP packet. And now there are a couple of different solutions. There could be GRE tunnels, different types of GRE tunnels. There could be IPsec GRE tunnels with IPsec around. And there could even be VXLAN, although I'm not sure if anybody is using VXLAN here from the vendor side at this point. So as you can see, more and more headers are attached to each packet. Well, we're talking from a minimum of 24 bytes that are added. So this is the same IP header as before. 28 bytes, and here we're already at some 20, 40, 76 bytes. So you can imagine any byte that you add to a header might get us into problems with a payload towards the end, because if the packet already had the maximum payload that could be transported through the wide area network, now it needs to be split up into 2 packets. That's called fragmentation. It's a really old problem from in the internet or in IP networks. Usually you really try to avoid fragmentation at any cost. So that means in the first place, one has to tell all of the end systems in the data center to only send smaller IP packets, which of course will reduce the performance on the storage and the service side. In the worst case, we'll see fragmentation if the end systems are not willing to adapt to this smaller packet size. And that means that any packets that are larger than any contribution loads that are larger than around 1,300 packets, 1,400 packets might get fragmentation. And as we've seen in a test recently that is not public, unfortunately, the performance, the throughput performance actually went down to like half of the 1,000 byte performance when fragmentation started. And that's pretty much as expected, because now one packet actually splits up into 2 packets. And usually the overhead for any router or any SD-WAN system is actually per packet. So if you have twice the amount of packets, obviously that results in half the performance. So it's important to make sure that there is no fragmentation and that the solution actually works in your network with no fragmentation. The other question is, of course, how long does it take to encrypt and decrypt and to encapsulate and decapsulate the packets? That's something that is needed, and it's a normal processing overhead, and I think the vendors differentiate here just by the amount of experience they have, by the quality of their algorithms. So IPsec can be very compute intensive, and it's important to make sure that the latency introduced by encryption is minimal. In the best case, it should be performed in hardware, because a PC is not very well, an x86 architecture is not very well prepared to do encryption. There are some additions in the latest Intel generations for data centers, but typically in an endpoint running a CPE, you would not see the latest Intel data center CPU. So ideally, IPsec should be done in hardware if it's for gigabit speeds and beyond. So since we're talking about security, it's not only the performance of encrypting, it's also the question, how does the whole security framework function? It's important to support strong encryption. And we're seeing this at EANTC with our firewall tests. In any performance test, the firewall vendors love to use the very small encryption links, like with 40-bit or 128-bit encryption, but that's not realistic. So it will be very hard to convince a bank or a financial company to use weak encryption. So strong encryption requires more overhead and more compute performance. It's important that strong encryption is supported, and it's also important that the authentication works well, so that there is a public key infrastructure available to distribute keys to all of the branches. And of course, the minimum required security level is, again, to make sure that the tenants are isolated. So these are important security requirements that I'll get back to later. So the next point, if you remember the first slide from the heavy reading survey, is everything needs to be agile. People expect that the services should be activated very quickly. So one of the major problems of the telecom industry and a major differentiator from the cloud industry is that provisioning a service takes forever. If you go to Amazon and you commission an AWS workload, it takes a few minutes at most until it's available. If you call a service provider and select, I would like to commission an SD-WAN service, it takes, I don't know exactly, but I would say weeks to months traditionally, until you have an MPLS or any kind of leased line service available. So the goal is to decrease the provisioning time here. One thing that needs to be done still and cannot be accelerated much is the shipping time. So if there is a CPE required, it needs to be shipped to the customer. So that's time that definitely cannot be increased much. Maybe it's a logistics problem. But then everything after, once the solution is available at the branch site, everything here should be as quick as possible. So a CPE needs to be installed. It needs to call home. It needs to, in the best case, it needs to configure itself automatically. It needs to receive a site and tenant specific configuration. And it needs to run through some kind of turn on test. And then finally, it will become operational. So this should ideally be days because of the shipping time, or if there is no shipping required, maybe because there is a virtual endpoint, it should be hours to minutes. So for the telecom industry, that's actually a quite interesting challenge because they are not used to doing things this fast traditionally. But it's certainly going to win a lot of customers if an SD-WAN service can be turned up very quickly. So each of the green milestones should ideally be hours to minutes, and the red milestones should be days if we have a physical CPE, if we have a virtual CPE that can be sped up to hours. So the next question, and one of the most interesting ones for me, is resiliency. Because anybody who comes to me and says, oh, we have something very cheap, it runs over the internet. Maybe I'm getting too old. I usually think like, well, the internet is not very highly available. At large, yes, it works very well and maybe better than some service provider solutions sometimes. But in fact, if you look at a certain access circuit, there's a pretty high likelihood that it will fail due to some construction work or whatever can happen. And sometimes the internet also has routing problems, not too often, but sometimes. So it's important to have redundant connectivity if there is anything important to be run over this SD-WAN service. So on one hand, redundancy starts with device redundancy. So CPE high availability is usually created by connecting two CPEs here. So we have two CPEs that are terminating the service. If one of them fails, I don't know, whatever, lightning struck, power outage, power supply fails, whatever can happen, then the other one will take over. So that's the first level. The second level is redundant connectivity. So there should ideally be two independent paths to the head end. And these two paths are with SD-WAN most often constructed using the internet for one of the paths and a more reliable backup service like MPLS or a service provider operated service as a backup. Now, maybe this gets you into the same pricing problems that you started with, trying to reduce them. So usually the MPLS backup has a lower throughput, which then results in the requirement that traffic steering needs to be very advanced and smart to only steer the most important traffic over this backup path if the primary path fails. This is actually an advantage if an enterprise commissions a service, SD-WAN service that is run by a service provider and not just by the enterprise or by a third party, because then the service provider can rely on their own internal infrastructure. So in some cases, in some countries, it might also make sense to have two internet paths that are just independent of each other. Let's say there is a mobile and a wired connection. Let's say there is a connection from one ISP and from another ISP using two different infrastructures. So these are also options. In any case, the question is what happens with the backup path if it's not needed? So in the end, as an enterprise, I'm actually buying two services, but I'm only using one. That's kind of a waste. So an active-active support is very interesting and helpful to increase the throughput. So let's say I have a lot of bandwidth over the internet, but I still have some bandwidth over this backup network. And maybe in some cases, it might be lower latency, it might be more reliable, lower packet loss. So it makes sense to use it all the time, not only if the primary one fails. It's not like in the old days an ISDN backup that I pay money for volume-based. I pay for it monthly-based, typically. So an active-active support helps to load balance the traffic and to use the best available link for at any given time for any specific protocol. Now, in the case that we do have a failover, it's fairly important that there will be a low failover time. And without sharing too much, that was one of the major reasons why the vendor that I wanted to talk about their results declined publication today. You know, their failover time wasn't as good as they wanted. So basically, there are quite a few things that need to work together for a successful failover. I'll get into more details later. So the failover time can be in the order of multiple seconds, up to a minute. You cannot expect that failover time to be in the millisecond range easily. If any vendor is here who has a failover time in milliseconds, please come to me. I'd love to test you guys. The next question is, if this works in an active-active scenario and a slow failover and everything is wonderful, unfortunately, most problems are not black and white problems. So in many cases, especially on internet transit, it's not like the internet fails. That's pretty rare. I don't know if you can remember like when exactly you did have zero internet at your home, for example. But often with some service providers and in some countries, there might be brownouts. Let's say the network is congested, so the packet loss will increase. It's important to actually fail over not based on black and white criteria. It's important to fail over on packet loss or on some kind of performance monitoring criteria. And I'll get into some more details later on this. So performance monitoring support is an important aspect that should be taken into account. And finally, a very weird problem or a weird thing that we came across in our recent telco cloud tests as well many times is licensing. So a physical box is easily licensed. You buy it, you have it, you know the license is the hardware, because if you want to have another one, you buy another one, but you can't replicate it. In a virtualized environment, it's much, much more difficult because it's just a piece of software. So you can take the image, you could copy it a million times. So the vendor has to have some sort of licensing mechanism to make sure you only use the number of copies that you have actually purchased, requiring a license server. Typically, the license server is somewhere centrally located. And if the license server isn't reachable anymore, all sorts of problems can appear. So some solutions actually keep working for a while and you don't notice it, but after, let's say, a week or some grace period, they stop working. Some solutions start to degrade. They say like, oh, I don't have a license anymore. I don't want to be too nasty, but I only work at 0.1 megabits or some weird thing. Some solutions stop working immediately. So it's important that the license server architecture is working, the license server is accessible, and that the license server is also highly available. So the license server is actually an important part of the resiliency infrastructure if it's needed. The easiest point would, of course, be to just hard code an individual license in each image, but then you get into some other challenges with image management. So now, so far, we're talking about greenfield. And SD-WAN is a really neat technology because so many deployments are greenfield. We have this solution. It comes with a couple of boxes or images or whatever, and you just deploy them. It's an overlay network. Don't care about the old stuff that you have. But in fact, of course, the full power of any new solution is usually only unfolded if it also has some ways to integrate with the existing solutions infrastructure. So standard protocols are needed to interoperate SD-WAN with existing network elements both on the edge side and on the core side, on the head-end side. It's very important that multi-vendor support will grow over time. And that's actually an interesting part. All of the technologies that we're using in telecom today are multi-vendor. So if you have an MPLS solution, of course, if you have IP solution, if you have mobile wireless network attachment, they are all multi-vendor. They're based on standards. SD-WAN so far isn't really based on standards. So you're buying a whole solution, and then you're in a proprietary cloud. It may work very efficiently. It's nice to have somebody singular to control it, but it is single vendor. Now, at some point, let's say in a couple of years from now, you do not want to continue buying from the same vendor all the time, or maybe that vendor discontinues the product or goes out of business or whatever happens. Or maybe your company actually merges with another service provider and they have bought another SD-WAN solution. So at some point, multi-vendor support is needed and open APIs are needed for that multi-vendor support. So then physical and virtual CPE support is needed. I'll talk about later why exactly. But if a vendor only has physical CPEs or only virtual CPEs, that limits things. So it's important that both work side by side. And it's actually a good idea to integrate with existing services that may have used similar concepts prior to SD-WAN availability. So there have been other hybrid WAN solutions in the past, with leased line backups, with all sorts of backups that for endpoints that were important and of business critical. Integration also means integrating with new stuff. So especially the hybrid cloud, I think, is going to be something that you'll hear a lot from vendors in this week. So connecting, using an SD-WAN service not only as a transport solution, but using it as a solution to connect to a public cloud and to run public cloud services and private cloud services together, including and enabled by SD-WAN connectivity. So that's actually a really exciting and also pretty complex environment, and it's important that the integration works well. And finally, CPEs. CPEs are always a nuisance. Sorry about this. CPEs are great. We've tested many great CPEs if there are CPE vendors here. But CPEs are also pieces of hardware that sit there and they get old. And with a new service, you get a new one. And in the end, the cabinets in enterprises look like there are CPEs all over the place. And sometimes even multiple of them stacked for one service. So it would be really, really good if existing CPEs could be reused. And there are actually good developments on the universal CPE side where CPEs can carry any kind of virtualized workloads on top. And some of the vendors in the SD-WAN space are very much involved in this business. So they actually don't sell physical CPEs anymore. They just sell like, okay, if you have one of this kind of CPEs, we can work with them. And we can put our SD-WAN termination point as a virtual endpoint. So that reuse might be interesting. And each of these points might be a knockout criteria by itself or an enabler by itself for a given application. Maybe in some use cases you might say, like, none of this is interesting for me. I don't care. But in some cases, if you already have like these 1,000 supermarkets and they do have an existing CPE, and you do not want to roll out CPEs to any of them, to every of them again, because that's a whole lot of time and money, then it would be really cool if the existing CPEs can be reused. So getting towards the end of the requirements, but you see there are a lot of requirements to be listed to start with. Feature sets. Feature sets actually got 2 slides from us because there are so many add-on features that might be interesting. Because the moment people understand SD-WAN, the moment they start deploying it or considering it, they say, oh, wait a moment, but I used to have this kind of feature before with MPLS. Now, can I have the same with SD-WAN as well? I used to have this kind of feature with my leased line. Can I have the same as well with SD-WAN? So QoS, quality of service and prioritization, is pretty important for any enterprise that has mission-critical services, and I don't know any enterprise that doesn't. So quality of services is always important, independent of what the underlying infrastructure is. High availability, we already talked about. Performance monitoring is important for the enterprise to understand what's actually going on. How does the service deliver? And at EANTC, we do troubleshooting with enterprises. So we often get into, not often, but we sometimes get into situations where enterprises call us and say, like, things don't work. And they always blame the network. And we don't understand why, because we think our network is great. And that's usually the case when they lack performance monitoring. So they actually don't have a way to understand, like, how well is the solution working. Then I talked already about firewalls and security. Firewalling is extremely interesting because the firewall industry is advancing very quickly with the threats that we're seeing in IP today. So intrusion detection, intrusion prevention, application layer firewalls, unified threat management, rejecting distributed denial of service attempts, all of these are concepts that are maturing in the network security in the firewall space now. And if an SD-WAN solution has an internet breakout, it is the firewall, unless you want to buy a second box that is the firewall. So in that case, security is really important as a feature on the SD-WAN solution. Of course, if you only want to connect to a hub, then it's completely useless and not needed because the firewall will be in the central office. And finally, application visibility is an interesting question as well. You know, maybe there is a lot of bandwidth available. Maybe it's cheaper than before, but it's always limited. And you know, people can always use all of the bandwidth that's available, and suddenly it's gone, and you're reaching the limits. So it's always good to know who actually uses that bandwidth, which application is taking most of it. Is it a backup that's running the wrong way? Is it maybe a load balancing that doesn't work? Is it just internet video browsing, streaming that people are doing? Or is it a mission critical service that actually needs to get a bigger slot of the critical capacity? So application visibility can be quite interesting and important. So more features. Now some features on the actual transport network side. So IPv6 has been coming, for years. And I remember when Upperside ran conferences for IPv6, which is already a couple years ago, but still service providers are starting to deploy IPv6. And sometimes things get much easier if an enterprise actually can use IPv6, or also on the service provider side, things get much easier if you can use IPv6, avoid network address translation, avoid all sorts of management issues with scarce IPv4 addresses. So it's actually important to support IPv6, or it may be important to support IPv6 both on the underlay, like on the transport network layer, and on the overlay, on the client layer. Some enterprises are actually using IPv6 quite efficiently, especially those that have a lot of sensors, a lot of endpoints. Then WAN optimization. So still, WAN optimization is a big market. A lot of bandwidth can be saved by just reducing the overhead of transporting IP packets. So it's possible to compress things, it's possible to compress headers, it's possible to cache things, there are a lot of really advanced techniques for WAN optimization. Now, WAN optimization needs to be implemented in this SD-WAN solution. Otherwise, again, you need a separate box. The next one is traffic steering. As I said before, traffic steering is important to avoid congestion, to make best use of the bandwidth. And the path optimization and traffic steering should be based on multiple parameters. If a vendor solution can only optimize on packet loss, maybe that's not enough. Maybe they need to optimize on latency as well. Because even if you have a link that has zero loss, it might still not be good enough for a video conference between two enterprise branches because the latency or the delay variation or jitter is too high. And of course, optimization should always be done on throughput as well, and not only wait until it's over-congested. So another slide from Heavy Reading. They surveyed their participants, the survey participants, on what virtual CPE functions need to be combined with SD-WAN. So what people actually think from this large feature set, which ones are most important. And actually, firewalls are most important for people, especially advanced firewalls, unified threat management, followed by WAN optimization, like safe bandwidth that you don't need to waste, and the packet inspection, application-based steering. And the rest is just spread, and I think it depends on the industry sector which of these are important. So actually, these are two of the more complicated feature sets. So it's quite interesting to see these, and we haven't had the chance to test the combination yet. What we're testing these days is typically SD-WAN solutions, transport solutions, their manageability, their resiliency, but it's difficult to get hands on the more complex scenarios and find the time from the vendor side. So the last point, but I think one of the most important, is the user experience. Now, this slide looks at things from the service provider perspective. So the user is the enterprise CIO or the enterprise IT team. The user, the enterprise, needs to be able to access this. Previously, I talked about deployment time. How long does it take to actually provision, let's say, one additional branch location? It's fastest, and the overhead of the management on the service provider side is the lowest if the enterprise can do as much provisioning and management activities themselves. In the best case, the enterprise would just say, I have a new location that's at this geographical location, or maybe if it's virtualized, they don't even need to be that specific. It's like at this IP address, at this endpoint, I want to establish an SD-WAN endpoint. And the management system does everything by itself. The user, the enterprise, configures all of the features needed, let's say a WAN optimizer, a firewall, and all sorts of additional features, and it's basically deployed automatically. That would be really, really cool, but then it's also very complex. In any case, a user portal, an enterprise portal, enables them to monitor, hopefully, the key performance indicators to get some input from the service provider side. How well does the SD-WAN service actually work? And I think, especially if anything goes over the internet and maybe the actual end users in an enterprise are a little critical, like, is this thing going to work? If something doesn't work, let's blame it on the SD-WAN service. It's actually very beneficial to have a monitoring in place, centralized, offered by the service provider that says, like, last month we lost only this number of packets, the maximum latency was this, the average latency was that, and the service is doing good on all locations except, I don't know, this city. And then you can actually act on that city. So the reporting tools should ideally be provided on a per site, per VPN, per application basis. So that's a lot of data, and maybe sometimes you don't need that much. But it's really good, of course, if the solution can support this level of detail. And especially for larger enterprises, and if a service provider offers an integrated solution that is not only SD-WAN but has other parts involved, it's always good to have a northbound API to actually be able to raise alarms to some other management solution, to some OSS, BSS solution, and to any user application. So maybe if connectivity is stopped, maybe the enterprise can even delay backups. So they would say, we don't need to solve the problem on the transport layer that we don't have enough bandwidth left. We can solve it on the application layer. Maybe something is not that important. We can just stop it until our main link is up again. So that's why reporting tools, connectivity with a northbound API is important. So, and it says, here, our team said, like, must provide tools to integrate with existing cloud offerings. I think that's becoming more and more a very critical application of SD-WAN to integrate with the cloud. And any solution that is just isolated and has no plan to integrate with existing cloud offerings probably doesn't have much of a chance. So the last part on the requirements is actually vendor support and commitment. And I see an interesting tendency. In any case, when there is a new disruptive technology coming up, there are always startups. And the startups have often really good innovative solutions. But then the question comes up like, okay, what's going to happen to that startup? Let's take Viptela, for example, really cool solution. They were acquired. And now they continue under the hood of a bigger vendor who has a lot of experience, maintaining solutions for a long time. But what if they had been acquired by somebody else? What would have happened to their solution? So it's important to understand what is the vendor support in the long term. Enterprise CPEs typically live at the edge for many, many years. So if the solution isn't supported any longer, if a centralized license server doesn't work any longer, the CPEs are bricked, and a virtualized solution is bricked as well. So it's important, especially for physical CPEs, to understand how long are they being sold, what's the last ordering date, how long does the vendor commit to selling them, how long does the vendor commit to maintain them or to keep them in place. And especially for an SD-WAN CPE that has an internet breakout, so it has a firewall component, of course, daily updates are really important. So a solution that is not supported any longer cannot be operated any longer if it is in contact with the internet. So the vendor support and commitment might be one of those tedious things that nobody really likes to think about when introducing a new service, but it's going to be a big factor for the business case, because if you have to throw out and exchange all of the CPEs and the whole solution after 3 years because the vendor said like, oh, by the way, the innovation was so fast, we're not supporting this old model anymore, then it's going to become much more costly. And in general, we believe that network elements are likely to require frequent software upgrades. There is a lot of innovation. It is a complex product. There is a lot of opportunity for optimizing solutions and reducing bugs. So, and of course, the security bug fixes that are always coming up. So there will be a lot of software updates coming. And software updates cannot always require the system to be taken out of service. So the buzzword here is ISSU, in-service software upgrade. And on the CPE, maybe it's okay to take it out of service for, let's say, a maintenance window Sunday night at 2 a.m. or something. On the head end, it's much more difficult. So an in-service software upgrade is a way that a implementation can be upgraded without taking it out of service. So it continues to operate. And that's the only way to get to a 5 nines, like a 99.999% availability over the year. So on the orchestration solution, that's if there is a software upgrade facility, it needs to be planned. So software updates shouldn't just happen like it. You know, I don't know how often this has happened to you, but more than once my PC surprised me by doing important security updates, and suddenly it rebooted without me wanting it to. I hope this one survives. So this obviously cannot happen in a telco environment. So software updates need to be planned, they need to be automated, they need to be rolled out. So an orchestration solution needs to support that. It also needs to support configuration management. So if I make a mistake in a configuration, I'd better be able to roll this back, you know, and be able to understand what change was actually made by my intern on a Friday afternoon when the main IT guys left. So it's change tracking, version tracking, ability to roll back configurations is really important, especially in large-scale environments. And my colleague pulled out a LinkedIn diagram using SDN and DevOps tools to track configuration change. Everybody's using their own tools. Why couldn't we just use Git as an open source repository and with Python scripts to use that? I'm not sure if that's a good solution, but that's at least a thought, you know, to generalize configuration management in an open source and multi-vendor way as well. The last one is vendor commitment on product maturity. So much of the challenge in this industry is integration. And a lot of SD-WAN vendors are working with third parties for their CPEs, which is fine. I really like the white box movement. There are so many really, really skilled vendors in Northeast Asia who have sold hardware under, you know, major Western brands for many years, and now they say, like, you know what, we're ending this. We're selling under our own brand. It's as good as anybody's, and we actually have the skills to build the hardware. So, but still, it's important to understand which hardware am I using? How much is it mature? Is it just, you know, like the first series of a prototype with a PCB that has been defined by a startup, or is it something really solid that will actually work in the field? And I've been testing in the Middle East in conditions of like 50 degrees Celsius in outdoor cabinets and a lot of sand coming in, you know, very, very dusty sand that really makes its way through all ventilation openings. And so there is, especially in outdoor environments, it's really important to have a mature product that survives like different temperatures, for example. So that vendor commitment should be well understood, and it should be understood like also what's the roadmap of a product, how is it going to improve, is there a way to actually put something on it, like a daughter board or something to improve IPsec throughput or whatever. Okay, so that was just the introduction of the design requirements. I think we're going to move much faster from here, but I notice it's already 11 a.m., so maybe it's time for a coffee break already as per the scheduled agenda. So we'll break for 10 minutes and continue 10 after 11 with the understanding the solution parameters.